Okay, this is the first video for section 11.1. It's called Areas of Rectangles. Chapter 11 is going to discuss area, which is a topic that you've studied before, and many of the ideas in this chapter will be familiar to you. However, we will be incorporating more difficult concepts and mixing in concepts that you've learned in previous chapters in this class, so it will be more challenging than you've seen in the past. Let's see. The first postulate that they discuss in 11.1 is that the area of a square is the square of the length of a side, or A equals side squared. And you've seen this. All the sides of a square are equal, so if you just take one and multiply it by the other, you will get the area, and of course we phrase that as S squared. There's an area congruence postulate discussed in this section, which says if two figures are congruent, then they have the same area. And I think that makes sense if you know that a square has a side length of 4. Both of them will have an area of 16 units squared. This third idea is going to be very important in this chapter, the area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. How is that going to benefit us? Well, if you consider a shape like this, maybe you don't know the formula to find that shape. But you do know that if you drop down, if you drop down a line here, you end up with a rectangle and then a triangle. Shape 1 is a rectangle, shape 2 is a triangle. Well, you know, I'm quite sure, what the area of a rectangle is and what the area of a triangle is. If you add those two non-overlapping parts together, you end up getting the sum of the whole thing. And we will use that idea over and over again in this section. All right, on to the topic of the section, area of a rectangle. Oops, sorry about that. Area of a rectangle, as you will remember, is equal to the base times the height. The base and the height can be either side. It doesn't really matter. They both meet at 90-degree angles. So it doesn't matter which one you call the base or the height. I could switch it around and call it the short side the base, the long side the height. If you multiply the one dimension by the other, you get the area of the rectangle in its units squared. Alright, so hopefully you tried these practice problems, and let's see what we got here. Start off pretty easy. All of these are about rectangles. If I tell you that the base is 8 and the height is 7, then hopefully you can figure out that the area is 56, and I really hope that you put 56 centimeters squared. Next question. I told you that the area is 60, and we know that area is equal to base, which is 15 here, and height, which is not given. But if you divide both sides by 15, you end up getting that h is 4, so 4 centimeters. Next problem, very similar. This time I know the area and the height. If I take 120 and I divide by 24, I end up with 5 centimeters. Next problem, 144 is the area. I know one of the dimensions, so I'm going to divide again, and this time I will get 12, and that's in feet. And then notice if the dimensions are the same, then we not only have a rectangle, we also have a square. Next problem, base and height are given, so we just multiply. I've introduced a radical to it, so got to remember that first you multiply the coefficients in front of the radical, so 5 times 4 is 20, and then root 3 times root 3 is root 9, and then of course root 9 is 3, so 20 times 3 gives us 60. Hopefully you got 60, and that would be units squared. Next one, root 6 times root 3 should give me root 18, and I won't leave root 18 alone because that's got a 9 in it. So the root of 9 is 3, and then we've got root 2. Units squared. Next, I've given you some variable expressions. So here's 3x, and x minus 1, I'm going to distribute the 3x to both the first and the second expression. So 3x squared minus 3x. I guess I should really put units squared. And then let's see, y plus 1 and y minus 2. Y plus 1 times y minus 2. When I multiply a binomial times a binomial, I should get a trinomial from foiling. So let's see, y squared minus 2y plus 1y, firsts, outers, inners, and then finally lasts, or y squared minus 1y minus 2 units squared. Alright, next, find the side of a square if its area is 64 centimeters squared. Okay, so we have the answer, which we know that the formula for the area of a square is side squared. So basically we know that 64 equals s squared. How do you get rid of a square? Well, you square root both sides. So s equals 8. And there's no need for a plus or minus here because we're talking about lengths. And I do want to report this in the proper units, which looks like centimeters. Next, perimeter of a square. Now, we haven't talked about perimeter yet, but you might recall that perimeter is the sum of all side lengths. And if you look in a square, I'll call it P, perimeter of a square, there's 1, 2, 3, 4 sides that are all S. So it's equal to 4s. If I knew what s was, I could figure out the perimeter. Now, I don't know what s is, but I do know that the area is 144. And I do know the area is equal to s squared. So I'll square root both sides and get 12 units. And then, sorry about that, perimeter, of course, is 4s. 4 times 12 is 48. So 48 units squared. Oh, excuse me, not units. We do know that the unit is centimeters. And we'll just leave it at centimeters because it's just side lengths, not any units squared. Number 3, find the area of a square if its perimeter is 40 centimeters. So let's see, perimeter for a square we already know is 4s, and this time we know the perimeter is 40 centimeters. It's basically the backwards problem to number 2. We'll isolate s by dividing by 4 on both sides and get s equals 10. Now they don't want just s, they want the area. Area equals side squared, so that's 10 squared or 100 centimeters squared. Next, number 4, find the area of a rectangle if its perimeter is 30 and its base is 8. Okay, we haven't talked about perimeter of a rectangle. If you look at a rectangle, we've got a base here and the same measurement here. We've got a height here and a height here, so you may recall that it looks like this. 2b plus 2h gives you the perimeter of a rectangle. All right. We know that the perimeter is 30. We know that the base is 8. What we don't know is h. So this is 16 plus 2h equals 30, or 2h equals 14, or h equals 7. The question is, what's the area of that rectangle? And we know area is base times height. The base was 8, the height was 7. So we got 56 centimeters squared for our answer. That's the end of the first video. I will post another video with the second page answers.